Welcome to the Atomic Spectroscopy Product Overview for Non-Technical Employees. This is Captain Adams' ICP-MS animation of how an ICP-MS system works. Samples have been previously digested into an acid solution and placed in the autosampler. Using a peristaltic pump to draw the acidified digest from the sample tube and pump to the nebulizer minimizes contamination from metals that could be found in piston-type pumps. Sample is pumped through a nebulizer where an argon carrier gas nebulizes the sample, creating a mist that enters a temperature-controlled spray chamber. This spray chamber is designed such that the large droplets of nebulized sample are condensed and pumped away to waste, whereas the smaller, more fine droplets pass through the spray chamber towards the plasma source. After passing from the spray chamber, an argon dilution gas is added to precisely dilute the sample, maintaining a total dissolved solids or TDS level in the plasma of about 0.2%, providing a robust and stable plasma. As the fine droplets enter the plasma torch, the high temperature and energy quickly desolvate, vaporize, atomize, and finally ionize the sample. This stream of neutrals, stray light, and ions now pass through a series of cones, separating the vacuum area from the torch area. Ionized sample atoms, or ions, now have an overall positive charge. Unionized atoms and stray light can be filtered from this ion stream using a set of lenses that bend, steer, and focus the ion stream into the analyzer vacuum chamber. Inside the vacuum chamber, the ion stream passes through a collision cell where a helium collision gas is introduced. Helium is used to filter out large polyatomic ions, or ions with more than one atom bound together. These polyatomics are very large compared to the unbound ions, and therefore will have a greater number of collisions with the helium gas. The polyatomics lose so much kinetic energy from the collisions that they cannot escape from the cell. Exiting the cell, the ion stream enters the quadrupole or mass filter. The quad has a voltage and RF tuned such that at a particular time during data acquisition, only a single ion mass can successfully pass through the mass filter to the detector. At the detector, the ions strike the electron multiplier, or EM, releasing electrons that cascade down the EM, releasing more electrons. This cascade of electrons is then measured by the detector, and a concentration can be determined for that specific mass.